Okay, now beginning electricity in your tiny house. Please be careful. Always make sure that all power breakers and everything's turned off before you get started, okay? This is a 50-foot extension cord going to the shed, as you can see right here next to you. And we're going to run this up through the utility conduit that is put in place for this currently. All right, now once this is parked permanent, the utility will be permanently wired to it. Instead of a 6-2 wire, which I'll show you what that looks like in a minute compared to this, we're going to cut this off right here, okay? Now, this is a very cheap 15 amp coverage 50-foot utility cord roughly. So what you're going to have is you're going to have a black wire, a white wire, and a green wire. Okay, this is a 120 volt power. If it was 240 volt, there'd be a red wire in there, okay? This is the black is your line wire, the white is your neutral, and the green is the ground, okay? But now what we're gonna do is, just for the time being, for temporary power, we're gonna run that up into our tiny house, and we're gonna stub that in just like so. We're gonna go up there and we're gonna wire that in. That's gonna give power to our panel once we plug it in the shop, and that'll allow us to start testing circuits. Now I'm gonna take you through, I'm gonna show you what the circuit is next after we get power actually generated to our house. So let's go inside now. Okay, so now we're inside our tiny house, and we're going to start wiring this for the final finish. Now you might say, gosh, you've started this at the very end of this process. I'm going to take you through step by step pretty much every little nut, bolt, and screw that you would do detail wise to put this stuff into your house, okay? But I like to reverse engineer. All right, what you see here, this is called a suicide plug. Never do this, okay? I have this in front of you as a demonstration of what not to do. This is much safer, okay? If you have this on a 15 amp breaker, 15 amp extension cord going into this for testing, then you have circuit breaker protection and proper wire size and protection. If you do this, and you do this to a really long extension cord, and you run this in just direct into the box, as you can see, there's no circuit breaker protection, right? Here's circuit breakers. Here's your two bus bar feeds, all right? There's no circuit breaker protection. So we're going to remove that, okay? Like I said, that is for demonstration purpose only. All right, so we're going to tighten this back down, and we're going to take this out just like so. We're going to remove that. All right, like I said, never do that. All right, now what you want to do in your box, all right, as you run your circuits, when you're pulling wire, you're going to drill a hole through your studs, excuse me, midways. You're going to push them through, all right? You're going to push your wire. This is a 12-2 wire, all right? So that I would run that for a 15 amp circuit, all right? This is a 10-2 wire. This is much larger. You can put that on a 20 amp circuit breaker. See how much larger the wire is in comparison to the 12-2. See, it's smaller. I never would have encouraged putting 14-2 wire in a tiny house, all right? Now, so what we have at this point is we've got our wire coming in from outside. We're going to strip that, all right? We're going to strip it quite a ways back. All right. Now, as you can see here, much better detail than as I was showing you outside. You have your line wire, which is your black, your green wire, which is your ground, and your white wire, which is your neutral. In a 240, this would be considered a 16-2 wire, okay? This is a 12-2 wire, and as I said earlier, that's a 10-2 wire. The reason it's 2 is there's 2 conductors in your ground. All right, now a 6-3 wire, which I'll show you that last, which when we're done wiring this in a minute, I'll show you the actual size wire I would encourage running into this into a 30 amp breaker later. This is the type of wire that you will use in your tiny house. If you're going to do anything 240 in a tiny house, I encourage you to get a licensed electrician to work with. 240 volt can kill you. 120 volt, you can walk away from it, but you'll be very angry at the end of the day, all right, that you got zapped. All right, but if it was 240 volt, you were running in, you'd have another conductor that's a red wire. All right, so we're going to take our ground, and as you can see in this panel box, I'm going to show you this in a second, wired up. Ground goes here. Neutral goes into your neutral bus bar, which is the white wires, and your black wire, the line feed, is going to go into this 30 amp breaker. That's going to feed all these other breakers, and we're going to install breakers in a minute too. You're going to put a jumper wire between here, okay? I'd encourage you to put a number 6 size wire, and I'll show you in a moment what that looks like. You're going to run that between that to jumper that. That way this lights up both sides of the bus bar, because here's a bus bar, here's a bus bar. So breakers on this side are fed from this lug. Breakers on this side are fed from this lug. All right, so I'm going to wire this in, and then I'll show you how it looks in just a second. I'm sorry, I misquoted myself a minute ago. I said 6'2". It's 8'2". You would want to use for your tiny house. If you're within a reasonable distance to your electrical meter, you say, I will just say 30, 40 feet to electrical meter, then right here an 8'2" wire would be plenty sufficient enough to run from there into your 30 amp breaker. Further distances, I would encourage a 6'3" wire, and anything over 100 feet at that point I would consult with an electrician. So anyway, this would be the top wire that's going to go in final finish, even that right there for this linkage right here. But right now we're just getting this going to test circuits. As you can see, these electrical plugs and stuff that's sticking out currently. Alright, so what we're going to do is we're going to finish installing our breakers. All these circuits that says kitchen, fridge, micro, living room, fans, lofts, bath, all that is going to be on a 15 amp branch circuit here. Okay, see, so we're going to take that line wire that we would have stubbed in. We have grounds, we have our neutral, and then we have line. The line feed always goes through the breaker. Okay, so we're going to put those in right through those slots there, and it locks in. Alright, as you can see right here, just like that. Has a notch, and it hooks into that notch, and then it goes into the V groove. Takes a little finesse on some of these new ones. Just like that. I'm a big fan of Eaton. Is my favorite electrical. You can use Square D, Siemens. It's totally up to you. I'm just a big fan of Eaton. Alright, so at this point, now what you'll do is you'll run that line feed into the back of that, screw that down, and that lets power, sorry, hold it out, that lets power pass through to those circuits at that point, and I'll show you that in just a second once I tighten these down. Okay, now at this point, we're going to feed power into the house, okay? Now, I could take my multimeter and check the voltages, but I know we already have power. So what I'm going to do now is I'm going to turn the bathroom circuit on, because I know that circuit's good. Okay, now we're going to look and see, and right here, my wife's going to turn on the fan, and the fan's running. Then we're going to turn on the lights, and the lights are working. Now, also, I'm going to show you something right here in the kitchen. Now, these circuits are all on a branch together right here, okay? That outlet right there will be changed to a GFCI plug, and I'll show you what that is in a minute. That's a ground fault current interrupter plug. That needs to be anywhere there's a wet location. Okay, so we'll install one of those in a minute. But what I'm going to show you right now is if you flip on the kitchen, which is this next circuit down right here, you'll see that the charging unit's coming on. Now when we start back here in just a minute, I'll show you how that we wire an outlet. We're going to do it with the GFCI plug, and then we'll go from there to a switch, and then I'll show you a light, and the same principle applies for a light as for wiring a fan. And at that point, guys, you should be good to go. Get started with doing your own electricity in your tiny house. Okay, so just a recap real quickly before we move to putting in a plug is we're going to look at this box one last time so we catch up to where we're at. Is we've installed our wiring into the house. Now this is temporary power with an extension cord. Keep in mind that you'll want to install the solid heavy duty 8'2" wire later, and the black wire would go where the black wire is currently to the 30 amp breaker. The white wire would go up to feed the neutral bus, and the ground would feed the ground bus, okay, for protection. Alright, so with that said, what we're going to do is we're going to take our cover and put back over this so that nobody gets electrocuted or anything bad happens to them, because we've already stripped all our circuits running back, and you want to always keep your circuits neat. You want to strip the outer coating and pull that off, and then at that point you want to run your wire, and a good rule of thumb is about 2 foot, you know, a good 2 foot, strip that off, and that usually will get you in a small 30 amp service panel like this right here. And at that point, guys, we'll be ready to move to the outlet at this point. Okay, guys, so at this point, we've put the cover back on our electrical access enclosure. And we have right here the access coming in. We'll foam that, and then we'll put insulation back over that. So now we're moving on. I've left this open right here so you can see an example of how to drill and pull that wire. You'll just take a spade bit. You can do a 1-inch spade bit and pull your wires through. You can run a couple wires through the same hole. Just make sure to keep everything to your local electrical code. Right here you can see this has been stapled. How did I staple that? You want to keep that kind of center of the 2x4, and that way when you're screwing in, you're not going to hit your wire, and so on. All right, so we now move into the bathroom that's currently being finished up here. We'll be putting the vanity in and etc. Now, that wire that you've seen coming through over there to here, this is our feed circuit. Okay, you're always going to have a feed circuit coming to your other wires, because if you're going to be continuing from that, see, we continued from that over to here to our outlet, which is currently off right now, or I'm sorry, to our switch, which is off right now, and that feeds the fan and the light, which you've seen earlier in the video. Okay, well, because we're in a wet environment and this is a 15 amp circuit, we got a plug that's rated for that. So this is good for 125 volt up to it at 15 amps, and this is commercial grade, so this is above and beyond the code. Okay, so, and it's UL listed. All right, guys, so, I mean, this is, like I said, way above and beyond the Call of Duty for a tiny house, because a lot of places don't even have code for tiny house. The great thing about this is that if you follow this and you either do it with your electrician, or you're doing as I'm telling you to do and try your best to keep it to code when getting your tiny house insured, it's going to be a lot less drama at the end of the day. Okay? All right, so we're going to undo this because I was just currently having this where that it would feed electricity over. Now, should I touch that even though I know that the power is off? No, we should not. All right, I'm going to show you something right here to always be careful. All right, this is a multimeter. All right, that's an amp clamp, and here is your leads. Now what you're going to do is you're going to set this up to volts right there, all right? And you can see right now it says DC. Now every multimeter is a little bit different, all right? But you're going to select the AC, all right? And that's the model of my multimeter right there if you want to check that out, okay? All right, so what we're going to do now is we're going to take and twist these off, all right, very carefully. I already know this is off, but I'm just trying to show you safely how to test these things before you ever move forward, okay? Safety first, folks. Familiarity breeds contempt, and contempt can kill you, okay? So what you want to do now is you want to hook your lead wires in right there and test that feed line. And as you can see, there's nothing coming. So not only do we know the breaker's off, but we also know that there's no power to this circuit. So at this point, what I'm going to do now is we're going to open this plug, okay? Now, this outlet is pretty similar to a normal outlet, okay, with just a little bit of exception. See, it's a lot thicker, okay? A lot thicker. And so what we're going to do is we're going to affix most often the gold screw is your hot, okay? That's going to be the small input there. The large prong is going to be your neutral, which you'll see is a silver screw. The green screw is your ground, okay? Now, so what we're going to do at this point is I'm going to wire this into this. I'm going to show you how it looks, and then I'm going to get a normal outlet and hold next to it and show you that pretty much the same process I'm showing you is how you go from one outlet to the next. And then we'll move on to a switch, and then we'll finish with showing you a light, because that'll be the same as wiring a fan. Okay, now one other thing that I want to show you is you can see right here it says load and a line. The line feed always has to come into this first, and then any additional load goes into there. So our feed wire will go under the top where it says line, and our other outlets will go, outlets, switches, lights, etc. will go on the other side of the load. Okay, and that's very important to keep in mind, alright guys? So I'm going to wire this up, and as you can see, we've tied together our ground. Okay, so wire nutted that, stripped that, wire nutted that, and it's only got one wire coming out of the wire nut now. And then we've got our 2 line wires and our neutral, okay? Alright, so I'm going to carry on with this, and I'll show you how this works here in just a second. Okay guys, so you can see the plug at this point now, how it's wired. You have your line wires coming in, ground wire, which is the green screw, and your neutrals, which is the white, okay? So we're going to put that into place. We're going to screw it into our box, and now here's how to mount those boxes in the wall, okay? Now that we're to the point where we're wiring a plug into the box, as you can see here, the box is set out just a little bit. My tongue and groove that I'm putting in, you can see the thickness of it. Okay, well look at the thickness of this tile. All right, so it depends on the thickness of your wall how far that you want that out, because you want it to be flush, semi-flush with this. And you can see the screws on most outlets go a long way. But I like to keep everything shoved back in that box, and that way there's nothing here on this line that's even close to having a chance of touching or causing electrical fire. I'm just paranoid about that stuff, guys. Okay, so with that said, we're going to put this in place, and then we're going to put the cover plate on, show you how that looks. We'll turn this on, test the circuit, and then we'll go from there to looking at wiring a switch. Okay, so now that we have our plug installed and we have finished that circuit completely, we can now energize that in the house for good, because that we know our cover's protected until that we get ready to move. That'd be the only time you'll turn that circuit off again, and because once you move it to your permanent location, you'll need everything de-energized to put in the 8.2 wire and hardwire that permanent to your electrical service meter. Or if you're doing it at your electrical service meter right now, then at that point you have completely finished up. So at that point you can flip that circuit on. One of your circuits is ready to fire away in the house now for good. And we see right here that we have power, so we're going to reset this. Give me just a second, guys, get my finger off this. Alright, now that's reset. Now we can test and see if all our stuff works. Fan is working, lights are working, and that means that we have done our job right. Alright, so now at this point I'm going to move over here to a switch. Alright, now when we flip the switch, it's very simple. It finishes the circuit, okay? Correct? Alright, so with that said, what we're going to do is we're going to walk over here and look at a switch that is exposed. Alright, now this has feed coming from the electric service panel right now, but if you'll notice, I've sprayed the contacts with non-conductive, alright, so that makes it semi-safe for the moment, just while we're having these out for testing purposes. Alright, you can see the ground's been wire nutted off together, okay, and there is a ground wire coming over to the switch. You can see the neutrals have been connected together already, because it doesn't matter about the neutral, okay? What we're doing is we're finishing the circuit. Then we're letting that line wire connect to that line wire that's going to the line itself. So irregardless of whatever type light you have, I'll show you a light here in just a second, for example, that I have to install, that would complete the circuit, allowing power to go to the light and the light to come on. And that's the same principle that will apply to wiring up a fan, unless that it has additional wires for the fan motor itself, and it's usually marked in the instructions what color that is. It may be a blue or a purple or some weird crazy color that you just need to tie additional to your neutral or to your line feed. And that's it, guys. It's really that simple. And I'll show you the light, for example, what I'm talking about right now. Okay, guys, for our last example, before I end this video, we have a recessed light here, okay? Now, I'm going to turn the kitchen circuit on, okay? That breaker that we put in earlier, you can see the light is on, okay? And we're going to flip it to the off position. You can see that broke the line feed to it that we discussed earlier. All right, now, a note on this, of course, when you get the light, you're going to need to open it up and, you know, connect the connector to the light itself, and that's a matter of just popping the lid off for a minute and popping it right back on. But now right here, we have our ground wire, our line wire, the black one, and our neutral, just wired temporary for the moment, just for demonstration purposes of this type light, okay? Because wiring this light is pretty much the same as if you're wiring a regular outlet, okay? It's going to be the same, guys. Line, neutral, ground, okay? Now, if you have enclosure boxes like this, you can't just run the wire straight through that. That would be a violation of electrical code. So you can see right there, there's a plastic pop-in, okay? And this goes for your main service panel as well. Or you can use an NMT, and you may say, what's an NMT? I'll put a link to that in the video description below. There's various sizes of them for various different sizes in the electric enclosures. So guys, that pretty much concludes basic electricity for tiny houses. If you have any questions, please by all means put them in the video description below. I'll try to answer them for you. And the fan, wiring a fan up is the same principle. And if you, as far as the additional functions in some fans, there may be extra wires that are color-coded additional, maybe a brown, a purple, or a blue, and they're marked in the instructions as to where they go and what for. Pretty much that concludes tiny house wiring. And like I said, if you have any questions, just drop them in below. I'll try to do my best to answer them. If you are dealing with 240 volt power, by all means use a licensed electrician. If you're doing this yourself, make sure to follow electrical code, because one day you're probably going to want to insure your tiny house. And, you know, I mean, if it's shoddy wiring, they're not going to probably insure it, guys. So I hope that's helped to you. Until we see you again, make sure to check us out at Off Grid Contracting. And I hope you have a most blessed day in Yahushua's name.